these are the solutions to the quiz at the end of lesson 7.3. Now, question 1 was just C, 2 was also C, and 3 was D. Now, first calculation, number 4, we have an intensity of 120 watts per square metre. And we want B, we want E, where they're the amplitudes, so the maximum values. So we have the expressions for intensity, either 1 over 2c mu naught E naught, let's call it, being the maximum, and it's also c over 2 mu naught B squared. So let's start with the E squared. It is I times 2c mu naught, and that is 2 by 3 by 10 to the 8 times 4 pi by 10 to the minus 7 times 120 is going to be 90478. So that gives us E, that's the square, remember we take the square root now to get 301 volts per metre. Using the same equation, we're going to take Bm squared is going to be 2 mu naught I, and that is going to be 2 by 4 pi by 10 to the minus 7. Sorry, there's an over C there, over 3 by 10 to the 8 times 120. And that gives us B equals 1 by 10 to the minus 6 Tesla. Or if we didn't even want to take all of this last step, we could have gone from E naught divided by 3 by 10 to the 8 and gone straight to B naught. Either way is fine. Now, number 5, our intensity is 1 by 10 to the 3 watts per square metre. So the energy density is just I over C. So 1 by 10 cubed over 3 by 10 to the 8. That gives us 3.3 by 10 to the minus 6 joules per cubic metre. So then the total energy, let's call it capital U, is going to be the energy density times the volume. So that is 3.3 by 10 to the minus 6 times 5.5 gives us 1.8 by 10 to the minus 5 joules. Now, question number 6. Starting with intensity being power over the area, and that is power over the area of a circle, which is pi r squared. So it is 1.2 by 10 to the minus 3 watts over pi times 1 by 10 to the minus 3 squared. And that gives us 3.8 by 10 squared watts per square metre. And then B, the energy density, is just the intensity over C. So 3.8 by 10 squared over 3 by 10 to the 8, we have 1.3 by 10 to the minus 6 joules per cubic metre. And number 7, we have an intensity of 1370 watts per square metre. The area of the sail is 32 square metres, and we're told the mass is 5 kilograms. Now, firstly, the pressure is 2I over C if it's reflecting, so that is 2 times 1370 over 3 by 10 to the 8 gives us 9.1 by 10 to the minus 6, and the units for pressure, of course, are, since it's a force over an area, are newtons per square metre. So once we know that, force is just pressure times the area. And so that is 9.1 by 10 to the minus 6 times 32 gives us 2.9 by 10 to the minus 4 newtons. And then the acceleration is going to be force divided by the mass from Newton's second law, 2.9 by 10 to the minus 4 newtons over 5 kilos, 5.8 by 10 to the minus 5 meters per second squared. And finally, number 8, we've got electric field magnitude 0.2 millivolts, and that is 0.2 by 10 to the minus 3 volts, per meter. The diameter is 20, so the radius is 10 meters. So, firstly, magnetic field is E over C, 0.2 by 10 to the minus 3 over 3 by 10 to the 8. It is 6.67 by 10 to the minus 13 Tesla. Then we have intensity. Since we've got magnetic field here, we'll use that it is C, B squared over 2 mu naught, which is 3 by 10 to the 8 times 6.67 by 10 to the minus 13 squared over 2 by 4 pi by 10 to the minus 7, and that gives us 5.31 by 10 to the minus 11 watts per square meter. You can see all of these numbers are very, very small because really the light reaching the telescope is going to be very, very small in amplitude. So now we've got power is intensity times area. So we have it equals 5.31 by 10 to the minus 11 times pi times r squared, and r is 10 meters. So we have the power is 1.60 by 10 to the minus 8 watts. And then finally the force, which is I times A over C. If it's absorbing, we've got P over C, and that is now 1.6 by 10 to the minus 8 over 3 by 10 to the 8. It is 5.56 by 10 to the minus 17 newtons.